During this presentation, we're going to tell you the importance that math has in agriculture. My name is Allie O'Neill.
My name's Abigail Lanier.
My name's McKenna Edging.
And my name's Peyton Ballard.
Next slide.
Okay, first we need to talk about something that's simple yet very important, calculating bushels harvested. Calculating this is a crucial step for farmers of all kinds of crops. Why is this a crucial step? It's a crucial step because the more crop that you harvest, the more profit that you will make. It's also important to calculate losses accumulated. Next. This is an example that we got from one of our PowerPoints. Jeff hired 2 combine operators to harvest his 155 acres. He expected a yield of 41 bushels per acre. One combine operator harvested 80 acres with a 3% loss. The second harvested the remaining acres and had a 5% loss. First question is, how many bushels did the first operator lose? How you do this would be that you would take the 155 acres and multiply that by how many he expected to harvest, which was 41. And that gives you 6,355 bushels. The next question was, how many bushels did the first operator lose? To get this, you take the 80 acres that the first operator harvested, multiply by how many was expected, the 41, and multiply by the 0.03 loss. This gives you 98 bushels lost. The third question was, how many bushels did the secondary operator lose? To do this, you would take the overall amount of acres, 155, subtract it by what the first operator harvested, the 80 acres, and you would get 75 acres. You would multiply that by the 41 bushels expected and multiply by his 5% loss. This gives you 154 bushels lost. And the last question was, how much more did the second operator cost Jeff than the first if wheat is selling at $4.05 a bushel? To get this, you would take how many bushels were lost by the first operator, 98, multiply that by the cost that it's being sold by. That gives you $396.90 that were lost. And the second operator lost 154 bushels. You multiply that by the price, and that gives you $623.7 lost, which means that the second operator lost $226.80 more than the first. Next.
Okay, so next, this is something that every farmer needs to know. As they plant their crops, they need to know how much fuel they're going to use and how much the fuel is going to cost. So, so every farmer needs to know this, like I already said. The farmer also needs to know how much the fuel is going to cost where he has enough money put back for it. Next. So, this is another one of our examples we got from the lessons that we learned. How it works. You're using a cultivator to plant 580 acres of corn. You'll plant 32 wide strips traveled 6.5 miles per hour and use 1.7 gallons of fuel per acre. The cost of fuel is $1.34 per gallon. So the 2 questions that we have is, how many gallons of fuel will be used and what will the fuel cost be? So first, we need to multiply the gallons per acre, which is 1.7 gallons. Sorry about my marker, it's not the best. And then you need to times it by 580 acres. And then you will get 986 gallons. And then you multiply that by the amount you spent per gallon, so it would be $1.34. And then the answer to that one would be $1,321.24.
Next. All right. The next one we're going to be talking about is how much fertilizer you need on your crop. So knowing how much fertilizer to put on your crop is highly important to the quality of your harvest in general. And NPK is a major part in fertilizer itself because the nutrients needed in any plant, I mean, if you don't have the right nutrients, your plants aren't going to grow right and you're not going to have good quality. Next one. So, this is another example we had from one of our PowerPoints. Daniel applied 40, 80, and 80 units of fertilizer, and each of these stand for NPK, which is nitrogen, phosphorus, and potassium. He did this for units of fertilizer per acre on 400 acres. He used 4600 urea, which is a type of fertilizer, and that cost $220 per ton. The next fertilizer he used was 18460 of DAP, and that's also in those quantities. Each of these numbers actually stands for a percentage of the fertilizer and like the type of fertilizer and the type of element in that fertilizer. But he used that of DAP in $260 per ton. And the next one was 0060 muriate of potash at $165 per ton. So each different fertilizer costs a different amount. But the first question we have is how many pounds of bulk fertilizer did he apply? So what you're going to do to first calculate this is you're going to take the 80 units that you need of DAP and you're going to divide this percentage by 80. So you know how much percentage of DAP you're going to use in this overall amount that you have. And after you do that, you get your answer of 174 pounds. And that's how much DAP you're going to use. But after you have your 174 pounds, you need to know how much of that is 18% of nitrogen. So what you're going to do after that is you're going to multiply your answer, which is 174 pounds, by 18%. So you know how much is left that is actually, that's taken out of that, that's nitrogen. And that is 31 pounds of that whole 174 pounds, and that's actually nitrogen. So since you have another fertilizer that uses nitrogen, you need to know how much of that you're going to be using. And you're going to take that 31, and you're going to take the 40 pounds needed overall, and subtract 31 by that 40. And that's going to give you 9 pounds. So you're only going to need 9 pounds of urea. And then the next is really easy. Since you need 80 units of fertilizer for potassium, you're going to take 60% of this muriate and divide it into that 80%. Or multiply it. Yeah, multiply this percentage to 80. And that's going to give you 133 pounds. So after you get all those calculations, you're going to add them all together, and that's going to give you 327 pounds, and that's how much bulk fertilizer you need to apply to your field. The next, you need to find the price of the fertilizer per acre. So what you're going to do is divide the cost per ton of each fertilizer by 2,000 to get it in terms of actual per acre instead of per ton. So what you're first going to do is you're going to take the prices of each, and you're going to, like I said, multiply them, divide them by 2,000, and that's going to give you 11 cents of urea per acre, and then 13 cents of DAP per acre, and then 82 cents potash. Sorry, I got mixed up. But after you do that, you're going to multiply it by how many pounds that you calculated in your first question, and that's going to give you how much it actually costs per acre, and then you're going to add them all together, and that should give you that answer, which is, go to the next slide, please. $35.79 per acre. Sorry.
Next.
I missed that.
Okay, so now we're going to talk about another skill that's often overlooked for farmers, and that's time management. Time management is a skill that is crucial for a successful farmer. By knowing how to do this calculation, a farmer is able to manage his crop and his time more effectively. Go ahead. Okay, so this is another one of the examples we have in our lesson, and it's pertaining to time management. So, Larry used a 20-foot wide disc to disc 500 acres of wheat. He was able to disc 12 acres per hour. How long did it take Larry to disc all of his wheat? So a reason why this would be important is because if a farmer were to go out and disc his wheat, there's not enough light of day to, effectively do all of the acres that he needs to do. So in order to calculate this, you would take your total amount of acres, which is 500, you would divide that by how many acres he did per hour. So you would use the 500 divided by 12, and if you go to the next slide, that'll give you 41.67 hours, so 42 hours.
Okay, and our last class example was calculating how many bushels of crop can be stored in a grain bin. It's very important for all farmers because if you don't have enough room to put your grain in, then you don't have anything else to do with it. Next slide, please. So this is our last class example from one of our PowerPoints. Mr. Moore raised 800 acres of corn. His yield was 130 bushels per acre. He has a storage system that consists of 3 grain bins. The bins are 48 feet in diameter and 32 feet high to the roof, and the roof rises 10 feet. First question is, how many bushels are in one grain bin? To find this, you need to find the volume of the whole grain bin. So first you have to find the volume of the cylinder. That is pi times radius squared times height. So you divide this by 2 to get the radius and multiply by the 32 feet, which gives you 57,900 feet cubed. Then you have to find the volume of the cone at the top of the grain bin. To do this, you do 1/3 times pi times radius times height. And you use the same numbers to get that. This gives you 6,000 feet cubed. Then you add those two numbers together, and that gives you 63,900 feet cubed. Then you have to change that number to bushels because it's in feet cubed and you need bushels. To do that, 1.25 feet cubed equals 1 bushel, and that gives you 51,000 bushels per bin. The second question is, what is the capacity of his storage system? To get that, you just multiply by his 3 grain bins, what you got for the first question, which is 51,000, and that gives you 153,000 bushels. The third question was, how many bushels of corn did he produce? He has 800 acres of corn, and then you multiply that by the 130 bushels per acre, and that gives you 104,000 bushels. The last question was, will his crop fill the system? And he produced 104,000 bushels, and his system can hold 153,000, so he'll have 49,000 bushels of room left. Next slide. Those are the answers.
Okay, so some other fun facts and other stats related to math and agriculture. Math is not only used by farmers, it is also used by basically every job in the agriculture field. Every job from an ag economist to an animal nutritionist involves math in some way. Farmers will have to essentially double their harvest in order to feed the estimated 9 billion people in the world by 2050. That's a lot of math.
Next, we're going to have a question and answer segment. We're going to ask some people in the audience some questions about why agriculture is important in everyday life and in math in general, and how it relates to math. So, next question, or next slide.
That's it. That's our sources. Okay. Now, we're going to go over here. David, how do you think agriculture relates to math now after this presentation?
I think it's very important about how you use math to really fine-tune your fertilizer on what could make your crops grow most effectively.
Thank you. Yeah.
How do you think math is important in agriculture?
Well, I don't think anybody really realizes how much math it takes to be a farmer or whatever you're going to be in the agriculture field. But it takes a lot of math and time to figure out how much fuel or fertilizer or even time you're going to use in a day. So I think it's very important.
Thank you.
Thank you.
This concludes our presentation.